In this video, we're going to look at central tendencies using arithmetic mean of continuous data. So let's consider arithmetic mean for continuous case. So there are three methods that we're going to look into in this video. The first is called the direct method. The second is called the shortcut method, and the third is called the step deviation method. So what is continuous data? You will understand it as we go to solve the first method. So here, this is called a direct method. Now, I have a data for you here for you. I have classified 45 students, 45 students marks. Okay. Now the test was conducted out of 50. And you have the marks of the students here in this table. What we have done is we have classified like the people who got between 10 to 20 were 5. What I mean is there were 5 students who got marks between 10 to 20. And there were 12 students who got marks between 20 to 30. There were 20 students who got marks between 30 to 40, and 8 got between 40 to 50. So here you can notice that we have collected all the marks which between 10 and 20, and we have given a frequency for this interval 10 to 12, 10 to 20. So instead of individually marking each mark and putting a frequency, we have collected them under a class interval. So this is called class interval. Okay, and then you take the midpoint of this class interval between 10 to 20. Your midpoint is 15. So if it's like from 10 to 20, you take the midpoint, which is 15. Similarly, you take the midpoint for each of them, and you have 25, 35, and 45. Then we also have their corresponding frequencies. Okay. So what do we do in this method? In this method, you multiply the midpoint with the frequency. Instead of multiplying the marks, individual marks, we take the midpoint of the class interval and we multiply that with the frequency. So we are going to find the mean based on the midpoints. Alright, so this is helpful when the data is very huge and it's so hard to put each each individual data collected and their corresponding frequencies. You might need a lot of computation work. So to simplify, you can classify them under a class interval. Okay, so after you have marked the midpoint, the frequency, you're multiplying them and you're calling them as FM, frequency into the midpoint. And then you're adding all of this together. So to find mean, what your arithmetic mean, what you're going to do is you will classify your arithmetic mean as sigma FM divided by n, where your m is the midpoint, f is the frequency of each class interval, and n, which is the total number of population or number of people, and which is equal to sigma f, which is also called the total frequency. So here our sigma f is equal to 45. So our sigma fm is this number here. So 1435 over 45. This will give you, if you use a calculator, 31.89. So you can say that x bar approximately equal to 32. So this would be your arithmetic mean for this data given here using the direct method. So next let's see the other methods. Okay, in this method, which is called the shortcut method, what you are actually going to do is you're going to take an arbitrary value, or you can call that as an assumed mean, and you're going to subtract each of your midpoint from your class interval. You're taking a midpoint, so that midpoint will be subtracted by this assumed mean or an arbitrary value a. So I'm going to refer this as a. So midpoint minus the a will be the deviations that you will get. Then you're going to add up all these deviations multiplied by its frequency. So let's see an example. It will be more easy for you to understand. So I've taken here a class interval of 3000 to 3010. So let's assume these are like a production factory. This is the daily production of bottles, water bottles. So let's assume that, in a day, the factory can produce around 3000 to 3040 water bottles. That's production capacity. So you're looking at, for 45 days, how was the performance? So 5 days, their production was between 3000 to 3010 water bottles. And for 12 days, the production was 3010 to 3020 water bottles. And for 20 days, the production was between 3020 to 3030 water bottles. And 8 days, they had very high production of 3030 to 3040 water bottles. So the observation was done, let's say, for 45 days, which is like 1.5 months. All right, so this is our statistics for 1.5 month. Right, so first thing what we're going to do is we're going to take the midpoint of each of these class intervals. Like how we did in the previous method, we're going to take the midpoint. So the midpoint for 3000 and 3010 would be 3005. So you have all the midpoints here: 3005, 3015, 3025, 3035. Next, what we're going to do is we're going to assume an assumed mean of 3000, value 3000. And you're going to subtract each of this value from this 3000. So 3005 minus 3000 will be 5. Similarly, 3015 minus 3000 will be 3015. So our A here is equal to 3000. Okay. Once you have done D with M minus 3000, which is A, you would now multiply each of this value, which is D, with the frequency. Okay, so frequency multiplied by this D would give you FD. So what did we do? Let me just crack this in a nutshell. You had a class interval, you took the midpoint of it, then you removed 3000 or an assumed mean from it to make it a smaller number to work with. So it's easy for you to calculate. And you multiply the frequency with that smaller number. So this is your FD, which is frequency into that smaller number, which we call it as D. Okay, so you have all the FDs here. I think it's quite clear for you. I don't have to explain each of them. Once you have calculated, let me just explain this, 3020 to 3030, our midpoint would be 3025. Between 20 and 30 would be 25. This 3025 minus 3000 will give you 25. And the frequency against this interval is 20. So you multiply 20 by 25, you get 500. Similarly, you get 280 here. So all of this, if you add together, you will get a value of 985. And the total of all of frequencies, sigma f, is 45. Okay, so now let's calculate our mean. So here in this case, the mean is given by A plus sigma fd over n. Okay, this is simple logic. We have removed 3000 from each of the midpoint. So what we're going to do is, at the end, once you find the mean, you're going to add it with the assumed mean. Okay, so our A here is 3000 plus sigma fd is 985 over our sigma f is 45. Okay, if you use a calculator and simplifying this further, you will get this as 21.89. So you can call our arithmetic mean as 3021.89, or you can say the mean is approximately 3022. So this is our shortcut method of taking an arbitrary value and subtracting it from the midpoint. Let's move on to the next method now. So our last method, the third method, is called the step deviation method. Okay, in the previous method, we subtracted it by an assumed mean or arbitrary value. But in this case, what we will do is, further, we will divide our d by a constant value. Okay, so this will reduce our number into a more smaller number. Let's look at an example. So we have again the class interval, the midpoint, same as the previous case, the same data, and you have the frequency for 45 days. And now what we have done is, after you have marked your frequency and taken the midpoint, I have divided our d with m minus 3000 by 5. So I took the midpoint, which is 3005, subtracted it from 3000, so that made it 5. 3005 minus 3000 would give you 5. I further divided it by 5, so you get 1. So let me make it easy for you to understand. So let's put each of them here. So for 3005, my d here was 3005 minus 3000 divided by 5. So that was equal to 5 divided by 5. So I got 1. In the second case, it was 3015 minus 3000 divided by 5 would be 15 over 5, and that's equal to 3. Then in the third case, it is 3025 minus 3000 divided by 5, that is equal to 25 by 5, that is 5. And in the last case, 3035 minus 3000 divided by 5 is equal to 35 over 5, that is equal to 7. So you can see here, I have the 1 here, 3 here, 5 here, and 7 here. Okay, so we have now reduced our number into a much smaller number to work with. So I think it's now easy for you to calculate. You don't need a calculator. 5 times 1 is 5, which is our frequency into d, fd. So 5 times 1 is 5, 12 times 3 is 36, 20 times 5 is 100, 8 times 7 is 56. So you can see how easy was it for us to calculate using the step deviation method. Now, let's start to calculate our mean. So our mean, arithmetic mean, is given by the formula A, which is here, plus sigma FD by N times C. It's a very simple logic. We first subtracted by 3000, then divided by 5. So here we're going to reverse the process. We're going to first multiply it with C, which would be 5 here, and then add it with 3000, which is A. So our A here is 3000 and C is equal to 5. So this would be given by 3000 plus our sigma FD is, this is our sigma FD, 197 over, this is our sigma F, or you can call it as N, which is 45 times 5, right? So you can further use a calculator, or this is more easy to calculate, divided by 9. So you'll get your answer as 3000 plus 197 divided by 9 would be 21.888. So you can call it as 21.89, which is 3021.89. Therefore, our X bar can be approximated to 3022. So those are the three methods. So these methods can be used when you're trying to compute using data in your statistics. Thank you for watching Math Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.